back, and we are moving into our second conversation for today. We're joined at this time by environmental consultant and retired meteorologist Frank Tench, well-known name and face. And today, given the recent eruption of Volcan Fuego in Guatemala, it's a great time for us to be able to kind of have a better understanding as to why these things occur and what the threat is for us here in Belize. So thank you for taking on the challenge.
Thank you, Marlene, and good morning, Isani. I want to start by probably explaining what is a volcano, because that would probably be something that a lot of us are not accustomed to, and volcanoes are not a natural hazard in terms of Belize's lifestyle. Nevertheless, it is a factor of the hazard in the other neighboring countries.
Yeah.
I just prepared this slideshow to kind of explain.
Okay.
Answer such a question. What is a volcano? It is literally a mountain or a hill, but within that mountain or hill, there are extremely hot gases and magma is a term used to describe the gases that are within that mountain or hill. There are times when that magma, it's always beneath the Earth's crust, Earth's crust and mantle. And
it's the core, right?
Well, the Earth is divided into crust, mantle, and core. The core is at the very center of the Earth. For scientific purposes, they say they divide it into five layers: the crust, the upper mantle, lower mantle, upper core, lower core. Textbooks, school books would just classify it as three: crust, mantle, and core. So let's leave it at that: crust, mantle, and core. Between the mantle and the crust is where the magma generally is boiling up.
Okay.
At any one time. At any one time around the Earth, there are about 50 to 60 volcanoes actively churning up or releasing magma. When the magma comes out of the top of the volcano, the term volcanologists use is extrude. Extrudes from the volcano, the name changes. It becomes called lava. And
so it's magma when it's in the volcano. Outside, it's lava.
Yeah.
Okay.
And it's molten rock, basically. Right?
Yes, it's molten rock, gases, and other material that are just boiling up within the Earth's mantle.
Yeah.
And the temperatures of a magma are extremely high.
Yeah.
A little later, I'll give you a little breakdown of what the temperatures are like within a volcano. So you have magma within a mountain or hill. And I have to mention this because we have mountains, we have hills, and you may wonder why we don't have volcanoes. But there's a little bit more to it than just having a mountain or volcano. It has to have the magma within the Earth's mantle to generate a volcano, or a volcanic eruption, so to speak.
Okay.
So once the magma extrudes from the volcano, it becomes called lava. Okay. So by definition, a magma is molten rock associated with gas and crystals that's still trapped under the ground. If that molten rock makes it to the surface and keeps flowing, it's called lava. Okay, so we got that little clear. Magma within the Earth's crust.
Lava when it comes out.
So this is just a diagram explaining basically what a volcano looks like. So you have the layers of the Earth's crust. There's a magma chamber where it's literally a boiling house for all that magma. So every so often, the magma can reach through the conduit or the pipes and come up out the summit of the volcano, and you get a volcanic eruption. There are quite a few volcanoes in Guatemala that you could pass and actually see the ash coming out of it. But it's a daily occurrence, and it's not so active that it can present a health hazard. Yeah, question?
No, I was going to
Okay.
say to differentiate between what makes a volcano active versus inactive. Because you're right. Fuego, for example, and I know Pacaya, which is two of the three around Antigua in Guatemala, are active. In fact, people hike to the to the summit of these volcanoes to see it as a part of a tour.
Right.
Yeah.
And they're in some countries they actually have what's called volcanic tourism.
Yeah.
It's a business.
Yeah.
Yeah.
Dangerous business, but nevertheless a business.
Yeah.
So you have the ash coming out of these volcanoes. Quite often you can see it, and people do hike up the sides of these mountains to get the thrill of
Seeing the lava,
seeing the lava flow.
magma firsthand. It's magma because it's in the.
magma. It's when it's within the mountain.
Yeah.
Lava when it comes out.
Okay.
Yeah. So, and one of the dangers of these volcanoes is that sometimes the magma does not just come out
That's all.
at the summit. Sometimes it has sufficient force to actually break through the crust on the foothills of the mountains. And people have lost their lives even while hiking up these mountains because suddenly the magma can extrude along, say, the flanks of one of these mountains. And scientists have lost their lives actually trying to examine. They're so keen on getting to the top to examine the features of the volcanic eruption that a sudden volcanic vent along the side can kill you. So it's not just limited to the summit. Volcanic
it can be
vents
from the bottom.
exactly, or
in the middle.
somewhere along the foothills of the mountains.
Okay.
Because of its tremendous force, it's pressure, it's extreme heat, all
Gas.
combined, and gases all combined to cause the magma to extrude and come out into the Earth's surface.
Yeah.
Okay. Okay. So okay. All right. So, like I said, magma is an extremely hot substance, and it can reach temperatures anywhere between 700 to 1300 Celsius, or in Fahrenheit, between 1300 to 23 to 72 degrees Fahrenheit. And it's a very fluid substance, and because the chemical composition of magma varies from volcano to volcano, volcanoes have different properties. The volcanoes in, say, Central America may have different properties from, say, the volcanoes in Indonesia, or maybe the volcanoes in Turkey and Italy. It all boils down to the chemical composition of the magma and the temperature.
Okay.
All magma contains gases and a mixture of simple elements, namely oxygen and silicon. Those are the most abundant elements in magma. And therefore, magma types are classified based on the silicon content, the temperature, and the viscosity of the magma.
Viscosity, as in how liquid it is, which will be how fast it'll move.
Yeah, exactly. How fast it will move. Yeah. Like water tends to move faster than, say, petrol or engine oil because of the viscosity. Okay.
Go ahead.
Question? Okay, so this slide here just gives you a brief breakdown of the different types of magma. Mafic magma tends to be the hottest magma. It has a relatively low silica content and low gas and viscosity content. Mean temperatures range between 100 to 1,000 degrees Celsius.
Yeah.
That's generally the hottest type of magma. Then you have intermediate magma. This has a generally higher silica content, higher gas and viscosity content, and mean temperatures, as the name says, intermediate, between 800 to 1,000 degrees Celsius, or between 1,400 to 1,832 degrees Fahrenheit. That's extremely hot, still extremely hot. And the third one, felsic magma, has a higher silica content, high gas and viscosity content, and the lowest of the hot temperatures between 650 to 800 degrees Celsius.
Which is still very hot.
Still very hot. Now, most of the volcanoes that occur in Central America would emit felsic magma. Yeah, they're not very hot, relatively speaking, but
the hottest of the magma types.
Right.
Okay.
So, you know, in essence, magma is extremely hot. You don't want to ever make the mistake of letting that substance touch your body. You'd probably die instantly.
Yeah. And that brings us to one of the questions I had we spoke of the eruption in Guatemala. At the same time, there was a volcano that had erupted in Hawaii as well, causing quite a bit of damage. But there was a very distinct difference in the type of eruptions. What was the reason for that? And I know there's a specific I can't remember the phrase, but there's a specific type of lava that came out of the Guatemalan volcan Fuego, which caused as much damage and death as it did.
Okay. The type of magma that came out of Fuego was, as I said, felsic magma.
Yeah.
The type of magma that came out of the Hawaiian volcano would have been the mafic magma.
So it was slow moving. I mean, you could literally see it just creeping across the highway versus in Guatemala, it was just completely enveloped the village.
Yeah. And also the location of Hawaii with respect to Fuego. Hawaii is located on what's called a hotspot. And a little later, if I have the time, I try to explain hotspot and as opposed to where Fuego is located. Fuego is located near one of the fault lines, the subduction zones. And if you notice, Hawaii's volcanoes are literally in the ocean. They're in the ocean, whereas the volcanoes like Fuego are part of a chain of volcanoes in Guatemala. That chain continues into Mexico, continues south into El Salvador, even down to Nicaragua. And it's because that whole region forms part of a subduction zone. And volcanoes tend to form near subduction zones or lines. The case of Hawaii's volcano is a case of a volcano sitting on a hotspot. It's just happens to be an area where the magma has easy opportunity to extrude from the Earth's crust, and therefore we have Hawaii's volcano erupting now as we speak. Yeah. But they are pretty well prepared for it because they have been monitoring it, and it's been happening for quite some time now. And they can carry on their daily lives, even if the volcano is erupting. They just seem to have a measure of, how intense it's going to be and how far to move away from it.
Let me ask a question here. In the wake of the eruption in Antigua, Guatemala, there were several pictures that were floating around. I believe they were dispensed by the media. And they were quite jarring, to say the least. You look at all these casualties and they're covered in dust. Were these people killed based on the gas that comes out of the eruption, or is it the fact that it's the volcanic ash they may have breathed in or what have you? How do you explain what perhaps took their lives in that situation?
Okay, good question. As I mentioned, once the magma extrudes from the volcano, it becomes lava, and that lava generally floats down the sides of the mountain. There's also the magma that extrudes and gets into the atmosphere. Now, when that gets into the atmosphere, it becomes like a fountain of fire, and it's a mixture of volcanic ash, rocks, and gases, and that one is very deadly. That's the volcanic rock there is called tephra, and it's a one that it's a form of magma that kills, because the pictures you saw were actually showing that gray ash. And sometimes if it's so intense, you could actually see the flames from the gases extruding into the atmosphere, and that is what kills people more so than the lava. The lava, people live on the hillsides with these lava and can just calculate when to move out of the way. Although lava can move pretty quickly, but the volcanic ash that emits into the atmosphere goes up several miles into the atmosphere and then comes back down.
Yeah.
And
With
that
force,
kills
I would
with
imagine.
tremendous force. Yeah.
And that's what we saw with some of the videos. It was. I think there's even some from satellite where we saw with Fuego. It went all the way up and then just came crashing
And
down.
that's a killer. That's the killer in terms of volcanic eruptions. The tephra, the volcanic ash, and the gases, because it's gases that are also coming out with it. So if the rocks don't kill you and the ash doesn't suffocate you, the gases can kill you, and that's a deadly part of. So those images were probably the actual volcanic ash that extruded into the atmosphere. It went up several thousand feet into the atmosphere and then came back down. And this, if you're not prepared, if you don't know what's happening, you get caught by surprise.
Yeah. And it happens so quickly as
Yes.
Now, I think one of the things that we saw was, and that was really the question I wanted to ask you, what's the threat for us here in Belize? You know, when this volcano erupted in Antigua, or near Antigua, I should say, in Guatemala City and in some of the outskirts, they saw ash. They had a problem with ash falling in their area. Yeah. Have we ever had that experience in Belize? And what's the threat?
Yes, I think about 10, 15 years ago when I was at the Weather Service, a volcano erupted in Mexico. I can't remember the name. I'm not sure if it's Chinchon or Popocatépetl. That's how I'm pronouncing the word.
Wow.
This
Chichon.
is Chichon. That's probably the nearest volcano to Belize.
It looks so.
Then there's this one here, San Martin.
There's one by the border.
What?
I said there's one by the border here.
That's probably Guatemala. Okay, Tacana. Okay.
All right.
It's probably Chichon. But I remember there was this volcano that erupted in Mexico, and the ash reached as far as Belize, because the runway at the international airport was covered with ash for several days, and air traffic had to be restricted because.
Oh wow! And look at the distance between this.
And you see, these volcanoes emit the ash and they go up into the troposphere where weather happens, where the winds are blowing, and that, depending on how the wind is blowing, that can bring the ash into your area.
So what we're looking at is, this is Chichon,
Yes.
and it would blow all the way over to Belize, and we had ash.
Yeah, we had ash. We had ash on our runway for several days.
Yeah.
In other parts of the world, the ash from these volcanoes has restricted air traffic. There's several stories of airliners that have ingested the volcanic ash into their engines, and they've lost altitude. There's a very nerve-wracking story about this jumbo jet that ingested volcanic ash, because it's crystals, and these things can damage an aircraft engine. The aircraft lost altitude, and in all 4 engines, fortunately the pilot was able to restart his engines and land safely at an airport. But it is a danger from the volcanic eruptions.
So let's look at where Fuego was, if we can move the map a bit and see. So that was Chichon where we said, and this would be Fuego here.
Yeah. So Fuego is, I think, even closer to Belize than Chichon. We could probably use
It
this.
just depends how the wind is moving.
Yes. So when I heard about Fuego, my first thought was, depending on how high that ash got into the atmosphere and how the winds were blowing, that would be the main threat to us.
Okay.
Bringing that ash into our area. Fortunately, it didn't occur.
I was asking you before we started, is there any threat in terms of our waterways? We know that our watershed starts up in the Maya Mountains and it really comes through Guatemala. Is there any threat in terms of, or it's too far off?
There's another factor with volcanic eruptions. When that ash reaches back down to the Earth's surface, many times there are rivers nearby, and that ash can get into the rivers, and the river carries the ash for quite some distance. It's called lahars, L-A-H-A-R-S, lahars. And in villages or places that are within reach of those rivers, that can also be a form of pollution.
Okay.
I would guess, seeing the location of these volcanoes and most of the rivers that go in would be up here. So I would suspect that the risk is not so great as, say, with the volcanic ash, coupled with knowing how the winds are blowing at the time of when the volcanic eruption is. But that is also a danger for communities within a immediate reach of a volcano where there are rivers flowing. That ash can pollute the river, and it becomes volcanic ash. It's literally called a river volcanic ash because it's such tremendous amounts of volcanic material flowing in the river, and it's hot as well too.
Now, one of the things that we're looking at here, I mean, these are all volcanoes, and it's called the Ring of.
Okay, the Ring of
Fire.
Okay.
This is a part.
This is a part of the Ring of Fire. Yeah, I think I have a slide here actually showing you what the Ring of Fire looks like.
Because there are quite a few, conspiracy theorists that say that based on the activity we're seeing in the Ring of Fire, that there may be even more dangerous eruptions that may be coming. This is what conspiracy theorists say. Don't watch me like that, Mr. Ted. I don't necessarily believe it, but we've all read it, so it makes us worried of we've seen major storms. We've seen quite a number of the implications of climate change. Belize, for example, is having more, we're feeling more tremors than we are accustomed to in the past. So talk to us about what type of activity is really happening there, and what climatologists and meteorologists are thinking at this time.
Well, the climatologists and meteorologists will be more concerned about the effects of these volcanic eruptions on climate, the climatic impacts. And one of the most immediate impact would be on, say, temperature. A volcano that emits ash into the atmosphere is going to create a cloud, limiting the sun's rays from entering the Earth's atmosphere, creating a sort of a greenhouse effect, leading to warmer, colder daytime temperatures and not so cool nights, because historically the two volcanoes that affected climate significantly were the same Chichon in Mexico and Mount Pinatubo in the Philippines. Those volcanoes emitted sufficient ash to circle the Earth for 3 weeks, and it had an effect on the Earth's climate. There was another volcano in Indonesia, Tambora, the most deadly volcano in history. 92,000 lives were lost. That volcano is said to have actually affected the weather in the United States for 3 months after its eruption, and during the summer months as well, June, July, August. So there is a real concern about volcanic eruptions and its effect on weather or climate. So I mean, I haven't read the theories that you've talked about, but I mean, if that is so, then more volcanic eruptions, and people in climate change do bear in mind that although it's not so much a direct link as say with temperature or rainfall regimes changing, there is that effect that volcanic eruptions can have on climate change. And the volcanoes that are often spoken about with respect to that would be the same Mount Pinatubo in the Philippines and Chichon in Mexico, because both volcanoes emitted considerable amount of ash to actually have an effect on temperature and the climate. Yeah.
Okay, all right. This was quite a crash course on volcanoes. You know, I think as we've seen over time, quite a number of things that we thought wouldn't affect us, like earthquakes and tsunami warnings, have slowly become a part of our reality, or are becoming. And so it's important that we know our threats for volcanic systems as well.
Yeah.
So we really appreciate your crash course on volcanoes this morning. Anything else you'd like to leave us with this morning?
Well, I think you're more or less hit the nail on the head. We need to be. Volcanoes are not the type of hazards to us as, say, hurricanes.
Yeah.
But nevertheless, the impacts, such as, say, if that volcano was sufficiently strong to emit ash for a sufficiently long time, and if the upper level winds were sufficiently favorable to bring that ash in our direction, we would be at risk for some effect, suffocation, pollution affecting air travel.
Yeah.
In fact, the whole thing with volcanic ash among the world's monitoring agencies, it couples well with meteorology, because there are about 7 or 8 agencies around the world that keep monitoring the extent of volcanic ash in different parts of the world, and they issue advisories. Yeah. When the Volcan Fuego erupted, I was actually watching the reports issued by the Volcanic Advisory Agency, which is Washington, D.C. for this part of the world. And they were actually issuing bulletins on the severity and the impact it would have.
On air quality.
Because it has a direct impact on safe aircraft.
Guatemala City Airport was shut down for after the eruption. All right. Well, thank you once again.
You're welcome, my dear.
All right. We're going to go ahead and take a break, and when we come back, we'll have more wrap-up. So stay tuned.